Hello everyone and welcome to Module 3 of our Software Design and Development course. Today is a pivotal moment in our curriculum. We have set up our environment and discussed the life cycle of software. Now, we finally get our hands dirty with the core logic of programming. Today is about understanding the fundamental building blocks that allows us to turn abstract ideas into executable code. Our agenda today is dense but exciting. We are going to cover core programming logic and concepts, the foundational trial, variables, data types, and operators. Control structures that give software its decision-making ability, functions and power of modularity, basic data structures like arrays and dictionaries, object-oriented programming basics, essential debugging and clean code practices, best practices for beginner software building. Let's jump right in. Programming is essentially the art of giving precise instructions to a computer. While syntax differs, whether you are writing in Python, JavaScript, Java, or C#, the underlying logic remains the same. This module is designed to give you that universal foundation. We are moving from setup to problem solving, which is the heart of every software engineer or software developer daily work. At its core, every program follows a simple input process output model. We accept data as input. We transform the data using logical rules as process, and we return a result as output. Developing a programmer's mindset means learning to break complex real-world problems down into these smaller, sequential, and logical steps. Think of variables as containers for data. Whether you are storing a user's name, their age, or an API key, you are managing memory state. We use data types like string for text, integers for numbers, and booleans for logic to tell the computer how to interpret that data. Operators are then used to manipulate this data, performing math, making comparisons, or checking logical conditions. A program is static until we introduce control structures, conditionals like if or else statement, allow our code to make decisions. Loops like for and while loops allow us to automate repetitive tasks efficiently. This is how we build intelligence into our software. It allows the program to react differently based on the data it receives. One of the biggest mistakes beginners make is writing one giant monolithic script. We avoid this through functions. A function is a self-contained block of code designed to perform a specific task. By using functions, we make our code reusable, easier to test, and significantly more readable. Always aim to write functions that do one thing and do it well. Data structures are how we organize information in memory. We move beyond simple variables to use arrays or lists, which store collections of data and dictionaries, or hash maps, which allow us to look up data using keys. Choosing the right structure is key to performance. Using the wrong one can slow down your entire application. Object-oriented programming, OOP, is our way of modeling the real world. We use classes as blueprints and objects as actual instances. For example, a car class might have attributes like color and engine type, and methods like drive or bread. OOP allows us to encapsulate data and behavior together, making our code modular and scalable. No code runs perfectly the first time. Debugging is not a failure. It is a core professional skill. We use try except blocks to catch errors so that our application doesn't crash unexpectedly. Learning to read stack traces and utilizing the debugger in your IDE are the most effective ways to solve problems quickly. Code is read far more often than it is written. Clean code isn't just about functionality, it is about communication. Use meaningful variable names, stick to consistent indentation, and follow the style guide specific to your language, like PEP8 for Python. If your code requires comments to explain what it is doing, it might be a sign that you need to refactor the code to be clearer. The only way to master this concept is to build. We will be looking at mini projects where you combine variables, functions, and control structures. When you build a calculator or a to-do list app, you are not just writing scripts, you are synthesizing everything you have learned into a cohesive functional system. Best practices for beginner software building. As you begin building, keep these pillars in mind. Always break complex problems into small, testable functions. Handle expected errors explicitly. Do not let your app fail silently. Adhere to language-specific style guides. Always write code that your future self or a teammate will actually be able to understand 6 months from now. Document setup steps and complex logic for future references. Now, let's look at do's and don'ts as a coding fundamentals. Let's close our technical section with some professional hygiene rules, the do's. Always break problems down, handle errors, and write readable code. For the don'ts, do not hardcore values that should be constant. Do not nest loops or conditionals differ than three levels. It makes the code unreadable. Never duplicate code when you can create a function, and never ever commit broken or untested code to your main repository. To summarize this module has introduced the logical constructs that define the software engineering profession. We have covered the fundamental building blocks from data types and functions to object-oriented programming and debugging. This foundation is exactly what you need to move into the advanced topics of the remaining modules, including architecture, testing, and deployment. Mastering these fundamentals is your gateway to building reliable enterprise-grade software. Thank you for your attention, and let's start coding.